In example 3, you're given now problems where you need to determine the validity of an argument where there are made up of more than two simple arguments. So for this first problem, you're going to you're given this argument um, P and Q, Q and R, and P and R, which would be your three prerequisites, your three conditions. Therefore, P if and only if R. And that's essentially the argument you're looking to see as valid. So in order to go through that, it's really no different than when we did it for some of the other earlier examples, except now I do have three simple arguments, three simple statements in here that I have to, establish truth values for. So, starting my truth table, I'm going to come up with every combination of P, Q, and R's truth values that I can get, and then I'm going to look under each one of these conditions to see like where these are true, and then ultimately see, okay, if these are if all three of these are true, does this true by automatically, or if not, then it's not valid. If it is, then it is. So P and Q, I'm looking at these two columns, and basically for that to be true, both P and Q have to be true. Otherwise, it's false. So when you look at the truth table, these first two, because that's in this area up here, that's where P and Q are both true. Otherwise, for the rest of it, at least one of them is false. Either one's false, the other's false, or both false. When I look at Q and R, they're both true here. They're both true here, which means those are the only two instances where you're going to see that they're true. False everywhere else. And then when I look at P and R, so the first and the third column, both true here, false everywhere else. So these are, the truth values for my three conditions, my prerequisites. I keep on forgetting the term that they keep using, but um, so now all I'm really concerned about when I look at this statement here, P if and only if R, is I have to make sure I'm looking at a situation where all three of these are true at the same time. In this case here, there's only one instance where all three of these are true at the same time. I really don't need the rest of the truth table, for P if and only if R. I just really need this first, this first entry. And when I look at P if and only if R, now remember when I look at P and R now, for this to be true, either they have to both be true or they have to both be false. Here they're both true, so that is true. Now, I did include the rest of them if you want to know what those are, and basically, again, if they don't match, then it's false. If they do match, it's true. Even if they're both false, it's true. You can see the rest of them, but these truth values don't really matter for our purposes because I'm only concerned about the instances where all three of these statements are true at the same time. And there's only one case where they're true at the same time. And when they're true at the same time, this statement is also true. So because of that, this is a valid argument. Now, I mean, if this occurs multiple times, then it would have to be true every single time. If one of them happens to be false, then it's invalid. So looking at this next one, again, I'm starting with the same truth table because I still have P, Q, and R as my simple statements. And so I start with, every combination of truth and falseness that these can have working together. The first statement says if P, then Q. So that's only true if both of these are true, P and Q, or if this is false. If it's an instance where this is true and this is false, then it's a false statement. So that's why we get, this filling out here with these two being true, these two being false, and the rest being true. Q or R means that when I look at these two columns here again, I'm only looking for, as long as one of them has true for a truth value, the whole thing's true. It's only false when I have both of them being false. So when you look at this statement here, you're only going to see falses here and here. It's going to be true everywhere else. And R or P, I'm looking at these two columns in the same way. I'm only going to look for, I'm only going to be false if both of them are false. So They're both false here. They're both false here. So I was supposed to see a false in the third row from the bottom and in the last row, but true everywhere else. And so are my my prerequisites. As you can see, I have 4 instances where all three of these statements can be true at the same time. I want to see what happens with P. Now, I can just rewrite it here, but I just opted, just for the sake of argument, just to look at these values here now, because that's what I'm looking for. As you can see here, P is true for these two, false for these two. So as soon as I got one of these to be false, when all 3 of these are true, this makes it an invalid argument. So the argument is not valid at all. So, and that's all it requires, is one of them. Here I have to have 2 of them. It doesn't matter what the numbers are. If they're all true except one, then it's invalid. The only way for it to be valid is all of these would have had to have been true. The third one you were given required you to translate as well. And the argument is basically this: if you liked This Is Spinal Tap, then you liked Best in Show. And I didn't type these, by the way, so I copied and pasted these, so that's a typo that the book had. If you liked Best in Show, then you did not like A Mighty Wind. Therefore, if you liked A Mighty Wind, then you did not like This Is Spinal Tap. Is this a valid argument? So, well, I'm going to translate this. If you liked This Is Spinal Tap, then you liked Best in Show. So I translate that is if S, then B. Obviously, S is going to be that you liked This Is Spinal Tap. B is that you liked Best in Show. If you liked Best in Show, so that part's going to be if B, then you did not like A Mighty Wind. I chose to make liking A Mighty Wind just for continuity's sake, and I put the not sign in front of it to say if you liked Best in Show, then you did not like A Mighty Wind. Therefore, if you liked A Mighty Wind, so that's just going to be M, then you did not like This Is Spinal Tap. Since S stood for liking it, not S is going to stand for not liking it. And there's my translation. Now with the translation, I can start my truth table. So my simple statements are S, B, and M. So I set them up, much like I did P, Q, and R for the other examples. And now I'm just going to go through and take these 2 premises or prerequisites or conditions and I'm going to just say, okay, if S, then B. Now, looking at these 2 columns, again, this will be true as long as both S and B are true, or if S is false. If it's true and false for S and B respectively, then it's a false statement. So the pattern ends up looking like this. And you've seen this pattern a number of times with different letters, so hopefully that doesn't throw you off too much. Now, I notice that the next 2 statements, one of the conditions and the final statement, are going to have nots in them. So I need to know what not M and not S are. So I just put those in right away. So the next statement, if B, then not M. So I'm looking at this column here and this column here. And again, false if it's true, then false. True if it's true and true. Or if the B, in this case, is going to be false. So my truth table for if B, then not M would look like this. It's only going to be false here and here. It's true everywhere else, either because I have both of them being true or the B statement is false. So now I'm going to look at the final statement. Now, I don't have to calculate the entire truth table if I don't want to. I just want to focus my attention on the instances where both of these conditions were true. And I do have 4 conditions where that is true. So if I do the truth table, if M, then not S. So this is the condition. So if this is true and this is false, that's false. This is false, which makes the statement if M, then not S automatically true. True, then false makes this false. This being false makes it true. True and true makes it true. This being false. So you can see them all here. Now, I didn't need all of those. I just needed the ones that are associated with the instances where both if S, then B, and if B, then not M are true. And you can see in every instance there, I end up with a true statement. I mean, there's instances where this could be false, but they didn't occur when both of these were true at the same time. Therefore, they don't matter for me determining the validity of this argument. Every instance where both of these statements are true, this ended up being true as well. So as a result, this is a valid argument. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.